to introduce all the new projects we are funding this year in robotics. So they have been selected during 2017, and some of them have just started to work, and other ones, yeah, are about to start. And this is a very good opportunity to communicate to the audience the type of project we have, and also they can also get in touch to each other to collaborate among themselves, and for you, the audience, to, if you have similar problems, you work on similar issue, then you can also come and discuss with you, because we will first have a marathon presentation. Everybody will have 3 minutes just to pitch what the project is about, the approach, and most importantly, the impact it will have. And then after this, we will go to the poster session. Some of them brought a poster, and it's an opportunity for you as well to discuss more in depth after this very short introduction. Just for your information, this session will be taped, so will be recorded, and we will publish the recordings after, so that for your project is also a first visibility to the outside world. So that's a good outcome. In the past, we used to have interviews, but we don't have time to interview 23 projects. So anyway, the importance is to have the right message in your pitch. So it's tough. It will be very intense, and I trust everybody will stick to the 3 minutes so that we are done in time and everybody has a chance to present this project. So thank you for respecting that, respecting your colleagues as well. And so I think if I see the last presenter coming, I will ask him to join in. But it's already quite good to have all the speakers, almost all there on time. So that's a good start. So we will present different types of projects. So you have been used with our normal robotics call, so ICT 25, 27, 28. So a majority of the project presented today will be from that call, but we are also inviting other projects. So we had a call on precision farming. So we will have 2 projects presented in this topic as well. We also have one project in factories of the future, and especially for manufacturing SMEs, so they will present it as well. And last but not least, a completely different type of project, and it's very important for you to be aware of that one, because it will also help you, and it offers services to the community. So it's very important for you to get this information, and it's about an infrastructure project offering an research infrastructure for roboticists, but Paolo will tell us more about that. And the total budget of all the present project is 107 million euro. So without further delay, we will start. So this was, we first start with the robotics project. This was the organization of the call, and I'll go block by block. So we will start with a type of project which was innovation actions, so more application driven. And the particular topic was end user driven application addressing market or technical barrier. And we have a number of projects in that area. So some projects working in search and rescue, inspection, logistics, and also ROS for microcontroller. So the first project to be presented is Robins, and Eki, you're welcome to start.
Hello everybody. Quick introduction to the Robins project. Objective of the Robins project is to open the maritime market for robotic inspection, and that's mostly dealing then with closing some technology gaps, but much more important, closing some regulatory gaps. What is unique in this project is basically we have the full value chain incorporated. That means we have research, we have technology provider like GE Inspection Robotics or Flyability. We have the asset owner, that means the ship owner, the shipyard, and we have Lloyd's as a regulation body. You see here, it's a combination of mobile crawlers, and it will be combined with drones. And the goal is to kind of capture the data and process the data and provide these into asset management system in order to take then the right decisions. I skip it. Impact is, as already mentioned, is getting robots into a ship for executing inspection, getting human out of confined spaces. That means basically cutting down outage time, increasing environment health and safety on one side. That means that's for the merit of the asset owner, of the ship owner and the shipyard. And the other side, having a kind of robotics as commodity, which can be deployed in the future and which will boost the robotic market. Thank you very much.
Yes, it works. So the next one is about embedded ROS. So welcome to your presentation.
Okay. Hello, everyone, and thank you, Cécile, for this opportunity. In this project, we are decoupling the name of the project that is going to be Opera with the name of the technology we are creating that is going to be called MicroROS, because we are not only creating a framework, but we are ambition to creating community of users extending and contributing this technology that is going to stay after the project. So let's talk a little bit about the problem statement and the goal of the project. Nowadays, a robot is a network of microcontrollers, a network of sensors, of actuators, and these sensors are based usually on microcontrollers. This network is usually combined with a larger processor, a typical CPU, and in this scenario we would like to use ROS. And here we are talking about ROS2, the new version of ROS. And the problem statement is that ROS2 doesn't fit in a microcontroller. And that is why we are creating this new framework that is going to be called MicroROS. ROS2 or ROS doesn't fit in microcontrollers because microcontrollers has a different set of tools and operating systems, and they have much less memory, real-time operating systems. Often they are battery powered and works in sleep-wake-up cycles and communicate through different networks such as low-pan networks. So the approach of this project is we have different partners involved in the project. In the hardware layer is going to be Accoutronic Robotics, Proxima, my company, is going to be in charge of the middleware layer of ROS, of MicroROS. Already Proxima is the default implementation for ROS2, so it's going to be easy to implement MicroROS on top of our middleware. And BOSS will be on charge of the MicroROS client library that is going to be similar to the ROS2 client library, but implementing several cool things like lifecycle and system modes, predictable schedule and execution, and embedded transfer libraries. And the benchmarking is going to be on PIAP, the policy university. So, the impact is going to be all of this.
Thank you. So the next one is Airborne. So the goal of that project is about search and rescue. So tell us more about that one, please. Thanks.
Yes, thank you for setting up this nice session. And this is Airborne. It's an innovation action and in search and rescue area. And actually, we have two main objectives. One is technical objective, namely to develop at TRL 8 a few selected robotic aerial technology for quick localization of victims buried by avalanche, so a very narrow application context by professional search and rescue teams. And we have on board essentially two main technology used for this purpose: passive technology, RECO, and active technology, ARVA. And the second, as much challenging objective, is to set up an innovative ICT, technology service network, to dispatch this technology at European level. And actually the main idea is that actually the vision is that the search and rescue area is an orphan market, typically characterized by small numbers or relatively small numbers, typically asking for very specific, robust, tailored technology, typically working in tight budget constraints, and typically characterized by many end users. So typically they are not attractive for big industrial players. They need to share technology, not to buy technology, and actually the idea is, again, to target this orphan market. The approach, in terms of technical approach, the idea is to co-design the drone with a sensor. Is a typical application where it's not possible to buy a commercial sensor and to buy a commercial drone and join together. Actually, you need for dealing with payload issues, for electromagnetic inference issues, to co-design the two. And actually, we have on board the sensor technology developers. In terms of innovative service network, the idea is to set up a technology hub network with many hubs that guard this bag, this technology, and run a kind of pay-per-use business model in which we do not sell the drone, but actually we give the drone and try to create business opportunities around the hub with a central unique somehow monitoring and supervising the whole activity. The impact, many, of course, aerial technology are TRL 8, new design solution of the sensor technology. The companies inside the project are indeed developing new sensor motivated by the application to provide a clear answer to the orphan market said before, and above all to pave the way for a new model of this new hub-based infrastructure that now start with this avalanche scenario, but in the future, to me, could be really extended to some broader context. Thank you.
Thank you so much. Next one is about blade inspection, but before the system restarts itself, I want to...
Okay, hello, I will talk about Sirius. Sirius is a project, CREOs is a project for developing a seriography robotic unit that does non-destructive testing on wind turbine blades. The objectives of the project is to develop a reliable and solid system that climbs the pillar of the turbine and deploys a robotic vehicle on the blade, which has an adjusted seriography unit and performs the seriography inspection. Now, the Sirius project is actually a continuation project of Dashwind. Dashwind was a project with also seriography inspection, but in a very different way. And during the field testing, we found a lot of issues with the previous setup. So we have developed most of the partners have redesigned and developed a new concept for performing the inspection more productively and with better results. Now the technical approach is that there is a robotic carrier that carries the robotic vehicle, and the carrier climbs the turbine pillar and connects and actually gets the robotic vehicle close to the turbine blade, which is stopped in a very special position, and then actually deploys the system, the robotic vehicle on the blade. Now, the main impacts of the project is first to achieve the continuous inspection of the turbine blades, which is important both during the life, let's say the 20-year life of the turbine, of the wind turbine, but also at the end of the life of the system, because actually if we have solid results and if we have an inspection system that is trusted by all the shareholders of both the government, the owner of the park, and the technical people, then we can prolong the life of the wind park, which means that we can produce energy in a very small cost. And we also want to reduce the number of accidents and improve the safety of the operation of these wind turbine parks. Thank you.
Thank you. So the next project, Spirit, is about industrial inspection. So tell us more about that.
Yes, hello, my name is Andreas Bichler from Profactor. I'm here for Christian Eitzinger, and I'm presenting the project Spirit. Project Spirit stands actually for a software framework for the efficient setup of industrial inspection robots. Basically, the consortium consists of 2 research partners, 3 technology providers, and 3 end users. So what was the motivation to write this proposal? Actually, today manufacturers are challenged by the increasing demand of variability, smaller lot sizes, customization, and of course, these manufacturers have to incorporate smarter technology to be able to adapt to quick changes and at the same time elevate the quality. So there's definitely a need for systems that enable zero defect manufacturing for smaller lot sizes. So the objective is, one of the main objectives is that Spirit actually aims at simplifying the deployment of such inspection systems by developing a software framework in order to be able to make the transition from programming inspection task to configuring just a task. And of course, one important objective is the full surface coverage of complex parts. So we want to create a fully automatic path planning systems which generate actually the coverage of the areas to be inspected for very complex inspection parts. So the inspection process is actually all image-based. So we have vision, X-ray, thermography. For this, we have actually 3 end users. The vision part actually will be carried out at the Central Research Field. There they have an assembly area where we set up a vision system and we are actually checking the proper mounting of the parts there. So as a second use case, we do the X-ray inspection at FSCC for aerospace parts, where we detect deformation of the metal core in the wings. As a third use case, actually, we implement the thermography systems at Pöhle-Udeholm. Actually, they have very complex metal parts there with dimension up to 3 meters, where we want to detect with our system small little cracks beneath the surface. So what is the approach? Basically, we have 2 main parts. We have the offline software framework, which basically is the offline generator for the paths. Interesting here is that we bring in as input the 3D CAD model and, of course, accurate physical model of the image processing system. With this, actually, we can accurately predict which area of the part will be inspected from a given point. So I would say inline in software framework is important because, of course, you have deviation from the part, you have deviations in the robot systems, and also the work cell deviates, and the computed offline paths would not really match. So we have to take into account this deviation, and by using the vision system, actually, you locally adjust the robot paths. And of course, as a result, you have a lot of 2D image. You have to stitch them together somehow or map them onto a surface and also visualize this in an intuitive way to the worker by using spatial augmented reality or just a monitor. So what is the impact? Well, the impact for the technology providers, they can provide the end users with less risky systems, which are more affordable. For the end users, they get systems where they just can integrate different inspection technologies in the same work cell. They can quickly switch to different parts. And of course, that makes savings up to 80%. And well, and of course, new robotic application can also be integrated, which have not been possible yet because it was just not feasible in an economical way of one. Thank you very much.
Thank you so much. The next one is, can you please?
Yes, good afternoon. where I'm going to present Big Place, which is a project. I'm presenting this on behalf of my colleague, Dr. Loreto Susperghi, who couldn't make it in the last minute, but I think you're going to be safe in my hands to go through this. So we're going to be talking about mostly about handling and how to improve the whole problematic of handling, making it safe, flexible, dependable, and so on. So taking a look at the consortium and highlighting the two partners that provide the use cases, this can give an impression, an idea of the impact that the project can have. So on one hand, we've got the ULMA handling system. This ULMA is working on e-commerce for preparation of systems to prepare orders for e-commerce, as I say. So that's something that's growing so fast, and almost half of the main players in e-commerce are already introducing robots in their processes. So handling is very important there. The other use case comes from TOFAS in the automation sector, where they have a scenario of kitting, which is also of high importance, as you can imagine. The goal of the project is that handling can be done far more flexible. So instead of making it very customized to just one type of object, the system has to be able to handle different sizes and different shapes and different weights of objects, also different qualities of surface, and in addition to that, different levels of stiffness or compliant elements, so far more flexible than it is typically considered. These are 5 key abilities that have been selected, which are relevant to handling, and that are going to be worked further during the project. There's configurability, adaptability, interaction, perception and cognitive ability, and manipulation ability. The way the project is going to be approached is more or less in the following fashion. In that list of 5 green boxes at the bottom, we see the multifunctional gripper. That's a novel gripper that will be developed during the life of the project, and it will be ready towards the end of the project. So that's a key cornerstone of the whole thing. Above it, we can see packaging, planning, and scheduling. Then there's human-aware motion planning, which will also be developed during the project, perception system, and finally grasping strategy. So all of these individually will be parts of the results of the project. And as you can guess, each one of these 4 areas need of a gripper, but the final gripper is not going to be available until the end. So off-the-shelf grippers will be used during the life of the project, and then finally validated with the one developed in the project. Thank you.
Thank you. Thanks a lot. So these were a set of projects which were the innovation action, so more user-driven part. Now we move to a second set of projects, which is the part which was more open to a generic research topic, and the goal is to improve the capabilities, improve the functionalities of the project. So we have 4 different types of project there, and the first one is by Nicolas. It's the memo project about.
Thank you very much. So I'm Nicolas Mansart from the GPTO team in LAS CNRS in France. The goal of our project is to develop generic methods to generate complex movements for robots with legs and arms in real time. Now the state of the art for this kind of problem are either with very ad hoc methods, with dedicated models, with a lot of tuning by experts, or either with a method with a very, very, very long time of computation. So we want to enhance genericity and real time with targeting 3 case studies where we want to propose demonstrator. First one is aerospace factory of future. The second is rehabilitation exoskeleton for paraplegic people. And the third one is inspection of civil engineering spots in dangerous area. Okay, so for all that, we need real-time replanning capability of the robot and we want to do that with a unique framework to enhance the genericity of the approach. How are we going to do that? Well, we settled on the frame of optimal control. So optimal control is a framework that was initially designed for simple system, either with slow dynamics, so like chemical tanks, or with simple dynamics, small dimension like energy kite. At the same time, it's more and more used in the robotics community for designing and then solving large-scale motion problems. It boils down to write a very complex, very large optimization problem that the best motion planner of the state of the art take hours to solve. So let's solve that on the cloud, offline, for thousands of occurrences of the motion problem by sampling at the same time the robot state and the state of the environment. We will obtain terabytes of data that we can use as a motion library that can be used online to guide the resolution of the optimal control problem. Now we have a big data problem to encode these terabytes of data in order to make them possible to embed them on the robot and also search in real time at runtime. These capabilities of, at the same time, generating a lot of data offline and storing them in a reasonable size, we call that a memory of motion, and that's the key technology we propose to develop. We are aiming at impact on three very different domains, once more because we are aiming at a generic approach for generating movements. First, in the aerospace factory of the future, where in particular Airbus, which is one of the partners of the project, is having problem when automating its factories to scale the robotic solution to the size of the product. And what they need, maybe the technology that they need the most now, is lightweight robots with mobile capability to navigate everywhere on the spot, and use tools that are designed for humans. In rehabilitation, paraplegics want to rewalk, of course, but they also need to rewalk for health problem linked to the lack of verticality. So in the first time and in the project, we will target the use of exoskeleton in medical centers and later at home. And finally, in dangerous situations like the extension of the tube in London, they now are sending humans, and we want to replace humans in the first time for inspection with quadruped robots. Thank you, Ryan.
Thanks a lot. Thank you. The next one is CrowdBot, and it's about safe navigation of robots in a crowd. So the floor is yours.
Thank you. So my name is Julien Petré. I'm from INRIA. I'm pleased today to present you CrowdBot. The project, as Cécile said, is about safe robot navigation in crowded public environments. And our objective is to, so we have two main aspects in this project. One is really technical. We want to improve the capacities of robots to navigate in highly dynamic environments by improving their perception capabilities, prediction capabilities, and navigation capabilities. And this will be used to answer the many ethical questions raised by the presence of robots in public places. And one important aspect in those questions is the scenarios we are working on. For example, you won't have the same expectation for the robot Pepper, which is one of the robots we will use in this project, moving in a public place which is being evacuated, for example. And maybe you expect that Pepper will not perturb the crowd traffic during evacuation. So you will have different expectations for a semi-autonomous wheelchair moving in the same situation, where the objective of the wheelchair is to be evacuated as the remaining of the crowd. So CrowdBot will develop the technologies to both enable navigation in crowded environment and address directly those ethical questions. Technically speaking, our approach is to work on three main aspects and to implement this framework represented by this figure. So we want to improve the capabilities of robot to track people at very close distance from the robot, to have a good estimate of the crowd state around the robot, And we will use crowd simulation technologies to make a prediction of the evolution of the state of the crowd around the robot so as to take decision on the navigation of the robot at the short-term level. The impact of this project are threefold. We expect to have a societal impact first, dealing with the acceptance of robots in public areas, but also to the population of impaired people by providing them some intelligent wheelchairs able to move in crowded environment, which is important for social inclusion, of course. We will contribute to mobile robotics, dealing with interactions between robot and humans. And we believe that we will open problems on motion planning, task planning, high-level task planning in crowded environment, or multi-robot coordination in crowded places. And finally, we also contribute to the research in crowd simulation, especially by coupling a crowd tracker with a crowd simulation, which could be useful for traffic management, for example. Thank you.
Thanks, Steve. Next one, it's completely different. It's about prosthetics. So welcome, Rafaela.
So MyLeg is a research and innovation action that has been granted in the ICT Call 25 on robotics. And the long title is Smart and Intuitive Also Integrated Transfemoral Prosthesis Embodying Advanced Dynamics Behavior. So I'm Raffaella Carloni from the University of Groningen, and I'm coordinating the project. And as part of this coordinated action, there are other 2 universities, 2 hospitals, 1 rehabilitation centers, and 1 of the world-linking companies in the prosthetic market. So the main ambition of this project is to develop a new generation of power transfemoral prosthesis, which can be intuitively operated, sensed, and trusted as the healthy and reliable counterpart in a huge variety of tasks. In order to achieve this general goal, we want to use osseointegration, which means to use implant on the femur bone, in order to enhance the human prosthesis interaction, the perception, and the motion capabilities. Second, we want to use implantable myoelectric sensors on targeted reinnervated muscles in order to provide the user with an intuitive control and to extend his or her cognitive capabilities. And third, we want to design this prosthetic leg by using variable stiffness actuators and composite materials, which are going to be used for both the actuators and for design of the sole in order to achieve energy efficiency, dependability, and adaptability to different tasks while the user is operating this new device. So regarding the expected impact of the MyLeg project, we believe that MyLeg will impact, first of all, society, because transfemoral amputees will better accept the prosthesis, the quality of life will most likely improve, and they will achieve and reach a higher degree of self-reliance. The reintegration in both society and in the labor market will be also facilitated. Second impact will be on economy, because we believe that with the MyLeg system, transfemoral amputees will need less support from formal and informal caregivers. And finally, we believe that MyLeg will impact the role of Europe as a leader in the prosthetic research and market. So I will be happy to talk to you later during the poster. Thank you.
So the next one is High Flyer. Is there, the main speaker is not here, so I get maybe he had the flu, I don't know. Is there anyone from High Flyer? Someone from maybe from Sevi? Sevi is in the team. No, Eki was there, but he had to move to the other meeting. So anyway, that's a pity because it's a super interesting project, which is basically reaching the unreachable in inspection, combining flying and rolling and snake-like robot. So I invite you to look into the, we have prepared a booklet, you should receive it, we are still looking for it, but it should be on its way to come here. So I am not able to give you the detail, but anyway, the presentation will also be available on the web, on our website. So we have first had a number of projects on innovation action, a second one on research, more open topics to improve the technology, and the third set of projects is again research and innovation, and we had 3 types of projects. Some of them was bigger project, and the goal of this project is to help the SMEs to get access to research. And in order to do that, they will use a mechanism which is called cascading of funding. So they will redistribute the funding they receive from the project to distribute it to SME to foster the take-up and give them access to the research. So that's the goal of these. We have 2 big projects on that, ESMERA and RoboUnion. We have another project, different types of project, about benchmarking, and the goal is to help everybody to benchmark. Again, it's also about community building, so there is a mechanism to distribute funding to contribute to benchmark and participate in benchmarking activity. And third type of project, they are the most standard type of research project to improve research system abilities. So we will start with the 2 projects we have in this research abilities. So the first one, sorry, I'm pushing on the wrong button, is Think, and it has some similarity with a previous one about this quadruped system. So welcome.
Thank you. So my name is Michael Mystery from the University of Edinburgh, and I'm happy to present the Thing project. So our main objective is to advance the perceptual capabilities of highly mobile legged robots through haptic perception and active exploration. So the inspiration for the project comes from the Thing character from the Addams Family movies. So this is, the one that can walk around on the table with this disembodied hand. So like as a human can feel the shape or the friction of an object through haptic exploration and tactile sensing, legged robots should also be able to sense the environment using its feet and its legs through haptic perception. So we're going to be using the Animal quadruped robot. This is a robot developed by ETH Zurich and Anybotics. The University of Pisa will be developing novel adaptive feet that can comply to the terrain and also sense the shape of the terrain. Oxford University will be fusing traditional visual information like LiDAR with haptic perception. Poznan University will be working on physical models of terrain in order to predict physical quantities like friction or compliance of the terrain. And all the scientific partners will be working on new control approaches in order to enhance the mobility of the quadruped robot using this new haptic information. So we're going to bring our robot into underground mines and sewers. These are very perceptually challenging as well as mobility challenging domains. And the impact there is to, of course, improve inspection of underground facilities, to make it more efficient and to do inspection that you could not do before. And also critically, we want to reduce the need for human staff members to be underground in these very dangerous environments. Thank you.
Thanks a lot. The next one is the second research project we have under this batch, and it's about surgical assistant.
So good afternoon. My name is Riccardo Murador. I'm with the University of Verona, and SARAS stands for Smart Autonomous Robotic Assistant Surgeon. So nowadays, during a robotic minimal invasive surgery, there are 2 expert surgeons within the operating room. The main surgeon seated at the Da Vinci robot console, teleoperating the robotic laparoscopic tools, and the assistant surgeon who is next to the patient helps the main surgeon now and then with standard laparoscopic tools. The goal of SARAS is to develop a system that allows a single surgeon to go through the whole laparoscopic procedure without the need of an assistant surgeon. To do that, we have to translate the medical knowledge into an engineering formalism, to design a perception module able to infer the status of the procedure and also to infer the needs of the main surgeon. And the third goal is to design a cognitive architecture able to make a decision and plan the motion of two new robotic arms holding standard laparoscopic tools. In this picture, this is just in a nutshell the approach of SARAS. So basically, we'll integrate a perception module based on machine learning algorithm, an advanced human-robot interaction, human-robot interface, a cognitive architecture, and planning and navigation algorithm. So we think that SARA has three main outcomes. So the first one is to decrease the cost per procedure, because basically the assistant surgeon is no longer needed. Then we can increase the surgeon awareness during the whole laparoscopic intervention thanks to virtual reality and augmented reality. And last but not least, we think that the semi-autonomous SARAS architecture could be also used in other robotic scenarios. Thank you.
Thanks a lot. Okay, now we go to the two other projects which will support the SME and offer services and redistribute money to SME. So the first one is, you have the sound.
Yeah. And turning.
I have to say I have not tested the, let's see how the entertainment works.
Hey. Wow. Okay.
You will have to sing then.
Fuck. Wow. Sorry. Come on. Here we are. But I don't know what's happening. Okay. I'm losing my first minute, sorry. Okay. Yeah, okay. Here we are. Okay, well, first of all, how many startups and SMEs here in the room? Okay, well, not too much, but pay attention because this presentation is for you, and we can talk for sure later in the poster session. Well, I'm Roy Rodriguez from Funding Box, and we are the coordinators of Robot Union. Robot Union is the Pan-European Robotics Acceleration Program. We are 15 partners from all over Europe, from 7 countries all over Europe, including researchers, accelerators, corporates, investors, and so on. In Robot Union, we are an acceleration program, and we will select 40 companies, and we will fund them with 4 million euros in 2 open calls during the 3 next years, from 2018 till 2020. We will prioritize 4 main verticals: agri-food, healthcare, manufacturing, inspection and maintenance, and if the company doesn't fit in any of these verticals, we also have a 5th one that is open disruptive innovation, where companies not fitting these verticals can apply. Which is our value proposition? The value proposition is based on funding. Companies can get up to 220,000 euros in equity free, and the best ones can get 1 million euros in private investment, and also in services. And the services are based in, for product acceleration, the companies will receive mentoring and access to facilities for developing their product. In business acceleration, companies will receive mentoring and training from top investors, entrepreneurs, C-levels. Among our mentors, there are people from Google, LinkedIn, Airbnb, etc. Companies will also receive exposure by participating in world events, by PR exposure in different media and so on, and access to public and private investment, and pilots with corporates, okay? In our consortium, we have 4 corporates, and companies will be able to do pilots with them. And which is the impact? The main impacts of the projects. We want to reach 2,500 companies, receive 300 proposals, accelerate 40 companies, help 8 companies to get additional private investment. We will also define what we call the Acceleration Toolkit to help regions, digital innovation hubs, and so on to adopt this same model of acceleration, and we will collaborate with other European initiatives. Okay, and to close, just invite the most well-known robots, musician robots in the world, Daft Punk, to let you know that the first open call will be launched in April this year, and to stay tuned, you can join the community in robotunion.fundingboss.com, and please feel free to contact me on Twitter, LinkedIn, or by email, and yeah, that's it. Thank you.
So thank you for this one. And then now we have a twin project doing similar activity, and so they will run in parallel, and I hope hand in hand.
Hello everyone, my name is George Mikalos. I come from the Laboratory for Manufacturing Systems and Automation at the University of Patras. And we have the honor and pleasure to be the coordinators of the ESMERA project. And actually, ERF seems to be the most suitable place for our project to reach the wider audience for perhaps the first time. And this is because ESMERA stands for European SME Robotics Applications. So as such, the SMEs that are, of course, active in Europe and work in developing novel robotic technologies are the focus of our project. And we are trying to provide them an environment that is motivating enough for them to develop their novel technologies. So we are giving them a problem to solve, what we are calling a challenge. We are giving them access to our competence centers where we can provide them with our technical expertise in robotics. And also we bring them in contact with our facilitators, which is a team of companies that are able to mentor and to support these SMEs into bringing their products to market. So we also give them direct funding through the Cascade Funding mechanism to develop proposals that they can actually use to solve the challenges that we set. So the way that we are doing it is that we have already identified 4 industrial areas under which we will create one challenge in cooperation with large EU companies. So you can see that we are going to have 8 challenges in total that the SMEs are going to try and address by proposing experiments. And we're going to do this in 2 phases. So in each phase, we will select 16 experiments that will receive a first funding for providing the proof of concept for their technology. And then out of them, 8 will advance to the next stage where they will get further support to finalize the development and mentoring to bring it to the market. And we will repeat the same process for another 16 experiments. So reaching in total 32 experiments and 16 challenge winners. So we will, for your information, the call is going to open this August, and we expect to have a first selection of experiments around October, and the second selection in 1 year afterwards, around November of 2019. So as I mentioned, our goal is to stimulate the European robotics developing SMEs and to provide them with access to funding, technological expertise, and mentoring so that we can do it in a way that is driven by the industry. This is why we start from the industrial challenges. And in doing this, we hope that we will be able to bring closer the technical excellence that has been built over the last year by our competence centers with these SMEs, and to contribute in this technology transfer paradigm that also supports the digitization of the European industry concept. So we would appreciate if we do not wait until the open calls in summer to come in contact. Our discussion starts here in ERF 2018. We look forward to meeting you, discussing with you here and also in the poster session. Thank you very much.
Thank you so much. The invitation is there, and yeah, and it's not. There might not be so many SMEs in the audience, but please also disseminate this information about these calls to the people you know, the potential users as well. Okay, now we move to different types of project. Yes, Jose. So this is about benchmarking. So here we will have a project which will make a difference for Europe in terms of benchmarking. Jose, tell us more about that.
So thank you for the invitation to come here and to share with you our project. So as Cécile indicated, this is focusing on benchmarking locomotion. So the idea is that we will follow this Cascade Funding approach in order to invite third parties to work together with us, with the consortium, in building a benchmarking ecosystem which comprises both facilities and methods for doing this. So in a nutshell, what we want to do is to link in a sort of causal effect technologies with system abilities, and the system abilities with how we meet the user needs in different application domains. So the main objective of our project is to try to quantify how different robotic solutions match user needs. So in order to do this, we have several specific objectives. We want to define which are the key system abilities in the context of human and robot locomotion involving stakeholders and users. We want to create a methodological framework for doing this, and this will be supported by a software suite. We want to create a couple of facilities, one for benchmarking wearable robotics and the other one for humanoids. One will be in Italy, in Genova, the other one will be in Spain, in Madrid. We want to validate also this framework with the help of the community, and then we want to create sustainable services for the future after the end of the project. So these are the different components of the benchmarking scheme that we want to create. So we have the benchmarks, the protocols, the robots, of course, the test beds, which are the different facilities that we'll have for testing the systems, and then the databases. So the approach that we will follow is that we'll be using this Cascade Funding. So roughly we have around 5 million euros in two different schemes to share with the community in building this infrastructure. So we'll have a couple of open calls. The first one will start mid this year, so July, September, and then we will have another one in 2020. The first one is to develop both the benchmarking software and the testing facilities, and basically we'll have projects during 18 months working with us. We'll provide financial support for this, and we'll be developing all these facilities, and then in the second stage we will validate what we created with companies and with other partners. So the impact that we want to reach is we want to replicate or be able to replicate scientific experiments to validate the different robotic platforms. This will help us also to compare different solutions so that we don't reinvent the wheels, but we can compare our solutions with previous results. We want also to target the design of new prototypes and identify the key technological factors that are crucial to achieve these system abilities. So we have already started to do this. You will find in several places this brochure here with a questionnaire. If you fill the questionnaire, provide your feedback to us, we will start discussing on the different aspects of this framework. Thank you.
Thank you so much. Thanks, Jose. Very good. And you prepared already a nice transition to the next presentation, because you were talking about certification, and in this call we had a specific topic calling for a shared facility for safety certification, and the outcome of that is a big project on that, and it's CoVR. So Kurt, the floor is yours.
Okay, thank you. So let's start with this project. So it's really about making sure that safety and fulfilling a requirement for safety is not a barrier for bringing in robotics into the real market. So that's what we're trying to facilitate and ensure. So the ambition with the project is to reduce the complexity in actually doing these safety certification of the robots that we need to do to bring them into market. We want to facilitate that by creating what we call a toolkit, a copper toolkit, which help assist the one actually developing the robots and using the robots on which validation procedures they need to go through to make sure that the safety certification can be reached. We want to develop some testing protocols which is more specific on which actions do you actually need to take to make sure that these robots are safe. So where you could say the toolkit is more about giving you direction and guidance, which kind of protocols do you need to use, then the protocols is more specific on actions you need to take to make this safe, complying to e.g. ISO standards and so forth. And the one final thing is that we want to create this as a European network or a hub, because there are so many different application domains in robotics, and we can't be expert in everything. So this is really also about facilitating and utilizing the facilities that we have across Europe, across these partners, but also future coming partners, which can help and maybe do the testing and validation of these robots to ensure that they fulfill these certifications. So one of the approaches in this is that we also have this FSTP funding. So actually we're going to give a bit more than 5 million in FSTP funding for developers of these kind of solutions. So it's really to facilitate that they get the support in creating new safe robots, but also in that case helping us testing the protocols and the toolkit that we're developing. There will be 3 rounds of open calls to help us on this. And the way we want to do this is to make sure that the protocols we do is something which can actually be used in the real world. So we have these what we call realistic trials, meaning that this is not only about doing lab trials, but also really trying to look into these real scenarios where we have all the different aspects which you need to take in consideration when you're out in the real life. Then it's this about the shared safety facilities. Again, some of the tests that we need to do may require that we have the proper equipment and the lab space and so forth to actually do measurements and so forth. So we want to open this up to make sure that the companies can easily get access to what is needed on that. And then finally we have this liaison with the occupational health and safety authorities to make sure that we also have all the stakeholders on board on this to make sure, again, that this about and maybe this uncertainty that might appear on safety, if the robot is safe or not, is not becoming a barrier. So finally the impact is that we want to make it easier to make the safety. We want to support all these people developing the robots, both the component but also the system integrators and suppliers in general, and then to promote that we have these shared facilities. So, thank you.
Thanks a lot, thank you. So this was another type of project. Now, yet another type of project, and it's about pre-commercial procurement. And I'm very glad to welcome Fabulous here, because the goal is to bring public authorities which have similar problem, they share the problem, and then together this project is going to help finding solution for them. So please welcome to present Fabulous.
Hello, my name is Anne-Mari Sanden and I will give you a fabulous presentation. So, Fabulous. It's about how cities can use self-driving buses in a systematic way. The goal is to procure the operations of an automated bus line by using PCP, that is pre-commercial procurement. So we have 6 partnering cities, which are Helsinki, Tallinn, Porto, Lamia, Kiesdal, and Helmond. And for technical support, we have Helsinki Metropolia University of Applied Sciences. So this is a 3-year project with total budget of 7.8 million euros, of which 5.5 goes for the suppliers. And regarding sorry, I think. Yeah. Yes. So about PCP, a few words. So it's a method for public sector procurers to buy research and development from several suppliers at the same time. IPRs stay with the suppliers, so no worries there. And it has 3 phases, so it has a concept design, prototype development, and testing. And each of these phases has significant budget available. So here you can see what we have. So we have, for phase 1, we take 12 suppliers, and we have quite considerable budgets for each of them. So it's 28,000 euros. For phase 2, we take 6 suppliers with even more budget, 251,000 euros. And this phase is actually for 3 months. And then for phase 4, we take 4 suppliers. So this is the pilot testing phase where we test these automated minibuses in 6 cities, which were also the partnering cities. And this is for 6 months, and you can see that the budget is quite a lot. It's over €500,000. So, how to join the fabulous challenge is to join our market consultation events. So there is one main event in April in Helsinki, and there is one follow-up event in Brussels, 14th of May, and then there is 2 webinar dates, April 10th and May 22nd. So here you can hear how we are going to do the procurement, what are stages, how to register, and how to reply for the tender. So in September and October, the request for tenders is open, so feel free to join and see how the fabulous works for you. So just here you can follow us in Twitter, Facebook, and LinkedIn. So thank you.
Thanks a lot. Let's hope we see these minibuses in our street in a couple of years from now. Okay, now the last part of our robotics call was about coordination and support action, and there we had 2 types of project. One was about competition, and the other one was about the coordination and support of the whole community. So we start with the competition one, which is building on the previous ERL league you know already, and extending with smart city environments. So thank you.
Hello, everybody. I'm Matthew Studley from the Bristol Robotics Lab. This project, we've got 10 different partners. They've all got a different way of pronouncing the project acronym. I'm going to go with SPARC, which I think is the Italian approach, and I think it's rather nice. So we're following on from the European Robotics League, which some of you may be familiar with already. The idea is that this is benchmarking through competition, so that we bring teams together in service, industry, and in emergency robotics. And they demonstrate the competencies of their systems on both functional level, so that's particular packages of functionality, and task level benchmarks. Now, what we're going to do next is we're going to extend this, and we're going to take it out into the real world. So we're going to have some smart city competition events. And in these smart city events, teams will be invited to demonstrate their robots in a context which is believable and relatable for members of the public. So this extends what we've done before and puts it into a context which makes it very real for people, and also which demonstrates a return on investment of the smart city infrastructure as well. So we're going to carry on with the European Robotics League. This will be extended slightly and updated to keep the challenges fresh. We're going to have new benchmarks. These benchmarks also change because we have to prepare the teams for the smart city events. And then the smart city events themselves, of which there will be 2, will be flagship events, and we're hoping to bring together different projects, including, I hope, some of the projects which we've seen represented today, to promote robotics and a real understanding of robotics to the peoples of Europe. A third objective of the project is that we need to establish for the long-term sustainability of the ERL. So beyond the project, what we need to do is establish funding mechanisms which will last into the future and provide for the ERL's continued existence. So then, in summary, the impact, we're bringing together different communities. We're promoting an understanding of the real capabilities of robotics as it is at the moment. Of course, we're familiar with all sorts of horror stories about the impact of robotics on our society, and also a lot of expectations which really are not at the moment underpinned by the state of readiness of the technology. We're going to demonstrate the technology to the stakeholder groups, both the cities, the infrastructure providers within the cities, and we're going to provide for the sustainable future of the ERL. So come and talk to me later about this, please. Thank you.
Thanks a lot. Thank you. So the next one now is Jose again, who is leading another coordination and support action to help the whole community, supports the whole community. So tell us more about it.
So thank you again. INBOTS is Inclusive Robotics for a Better Society. It is a big consortium with 25 partners in different domains. We want to contribute to creating public awareness and to bring together all the different stakeholders so that we can improve the uptake of robotics in our society. So we think that the evolution of robotics implies a closer physical, cognitive, and emotional interaction between the robots and the people and the humans. So this will create, of course, opportunities, but it will also create dangers and responsibilities. So we want to fight against the negative perceptions and the overestimated expectations in society about interactive robots. So I would say that the main objective of this coordination and support action is to overcome this lack of clear understanding and communication between the different stakeholders. In order to do this, we want to create and promote a debate on responsible research and innovation paradigm for robotics. And we will be focusing on what we call interactive robotics, which is basically service robotics in very close collaboration with humans. So we will be addressing different aspects of this interactive robotics. So we want to promote entrepreneurship, and we want to provide support to SMEs, as these are one of the key players in this field. We also want to promote debate on legal, ethical, and socioeconomic approach for these robots, and this in a very close relation with regulatory and risk management aspects. It was great this morning to see how we have to take care of the education in the different ages towards robotics. So we want to promote education from preschool to the labor market with robots and for robots as well. And then, of course, we want to promote the societal uptake of robotics. For this, we created what we call 4 pillars. We have a business pillar. We have an ethical, legal, and socioeconomical pillar, technical expert pillars, and end-user pillars. So our approach is to build on the capabilities of the consortium, but we want also to enlarge the collaboration. So we don't want to reinvent the wheel. So we want to establish collaboration with previous and ongoing projects and institutions in the field of robotics. So we have already established with EU Robotics and SPARC, with cost action related to this type of robots. Of course, there are very close links with the previous project that I was mentioning, the Eurobench project. But our aim is to try to cluster not only these projects, but the community around all these domains that I was describing before. So thank you.
Thank you so much. So after this range of robotics project coming up from our calls, so we are not now covering the call about precision farming, and we have two very interesting and very different projects, one on a large scale and one on small scale farms. So the floor is yours. And I hope you will bring Nutella to everybody.
Hi everybody, my name is Andrea Gaspari and I am an associate professor at Roma Tre University and I'm the coordinator of the project Pantheon. This project is about precision farming of hazelnut orchards. The ambition of our project is to change what the current best practice is for the management of large-scale hazelnut orchards. Right now, to take agronomic decisions, what is done is that a few representative plants are studied and then treatments are used in a homogeneous way for large sectors of the orchards. Clearly, this is a non-optimized approach that may lead to a waste of production and thus an economical loss for the farmer, but also to avoidable pollution and thus an environmental damage for all of us. What we want to do, we want to shift, we want to propose a new paradigm that will allow not only to monitor a few plants, but to reach the resolution of the single plants in terms of monitoring and control. How do we expect to achieve that? We will propose what we call the agricultural equivalent of an industrial supervisory and data acquisition system, control and data acquisition system. The idea is to have a fleet of robots, aerial and ground robots, moving around in the environment, collecting information and performing some farming operation. Those information will be sent back to a central unit where the data will be elaborated, the phytosanitary status of the plant will be figured out, and agronomic decision will be taken. It will also provide a decision support to the agronomists, for instance, to figure out if some specific plants have an anomaly in their status. So, what Pantheon will bring to the table is a new framework that will allow us to continuously monitor every single plant on a very large scale. Clearly, this will allow to promptly enable what are the limiting factors of each single plant, and then react accordingly with focused interventions. We truly believe that Pantheon can bring a significant impact on the way right now precision farming is for the management of hazelnut orchards. We expect that by monitoring every single plant, the average health state of the orchard should improve, and thus also we expect to have an increase of production. For the same reason, we expect to be using less vital sources such as water and to decrease the need of chemical inputs, and thus leading to a more environmental friendly management of the orchards. Finally, we expect to reduce the human burden by the automatization of tedious and repetitive operations that, even more importantly, on large scale now are not even possible. Thank you very much, and please join us on the poster session.
Thank you so much. And now the next agriculture project is for small-scale farming. So how can you help those people?
Hi everyone, and thank you for the opportunity to present the Roaming project. So the Roaming project is aiming at developing a robot for small farms, for example market farms producing vegetables, as you see here. And those farms are very demanding in human work and not very addressed in the robots today. And so the ambition of ROMI is to relieve the farmers in those farms and to bring new technologies with artificial intelligence and adaptive robotics to those farms, because we consider it's a very interesting environment for these technologies. So the objectives are to develop a modular robot, for example, for precision weeding, mechanical weeding at first, and also for crop monitoring, and we let open the addition of new tools and new applications. We also wish to extend the Nero drone to combine imaging from the drone with precise imaging from the robot to have a multi-scale description of the fields, and to build and engage communities of farmers, makers, scientists, biologists to join us on the project to build robots in their location. So the approach is to build robots in workshops discussing with farmers on their usage and to iterate the building of a robot on the 4 years of the project with evaluation of the performance of the crop monitoring, for example, in discussion with biologists. And so we wish to bring biologists and farmers around the robot to discuss the efficiency of the robot and to improve it. So we think it will have an impact both on reducing the painful work, which is sometimes discouraging to young farmers, and we wish to help them manage their crops using, for example, mechanical weeding, so environment-friendly processes. We wish to improve the safety, reliability, and manageability of agriculture technologies by having a very precise monitoring of the crops. And beyond that, we hope to bring farmers of small farms, which are often open to technologies, to bring them new tools and to create a new movement of, around these tools, because they are often very good at making things. So, and also to bring cognitive robotics to a field, which is, as I said, a very diverse and very interesting environment. And maybe we hope to see new ways for biology to bring new results from the farmers to the phenotyping research.
Thanks a lot. Thank you. Very interesting. So these were the two precision farming projects we are funding, and they were already started. The next call is Factories of the Future, and here we have an interesting project about manufacturing again in the context of SME. So Ali, let us tell us what your project will do.
Okay, so as the title says, this is the logistics for the manufacturing SMEs. If you want to know more about the project, of course, you go to the website. There you find a lot of exciting information. You can also follow our activities and stories on the Twitter or on the LinkedIn. So basically, our project is part of I4MS, ICT for Manufacturing SMEs. So basically, we want to deliver better and better ICT, new technologies to the SMEs. Our understanding is that the European manufacturing SMEs are one of the best in the world. The things they do, the things they create are amazing, but they lack the in-house expertise and resources to utilize advanced robotics. Logistics, material transport can be nearly 50% of the cost of the production, and big manufacturers are constantly trying to reduce it by either going towards the mass production or using mobile robots. But if you think about the SMEs, they neither have the in-house expertise for it, they do not have the infrastructure to test these things, and they do not have the financial access. So what we have done in the project is to create a network, a marketplace, which is a one window to a network of digital innovation hubs across Europe, which provide all the services starting to help the SMEs to develop innovative business models when they optimize their production. Also, the logistics solutions which can be accessed without much in-house expertise. How we run the project is like an acceleration program. We take the SMEs inside. In the first 2 months of these experiments, when we take an SME inside, we give them very small amount of money. We help them with matchmaking, develop their technical and business proposal, and then finally optimize their pitch. And then we cut off a certain number of them, and we reduce, for example, from 12 to only 8 or 6 SMEs. And then we start to invest a serious amount of money, something around 250K per SME, plus 250K in the amount of services we provide, so around $500,000 per experiment. And we hope that by the end of the experiment, we have validated and create a proof of concept with which they can go and find the financial investment, private investment, where we will help them also to the commercial implementation of the solution. And the main impact we are going to create is that we will make this whole process 10 times faster. Basically, from the current state, we digitalize everything. In principle, everything should be able to be developed and tested and validated on the computer screen before you have to go to the factory floor. Thank you very much.
Thanks a lot. And last but not least, as I announced at the beginning, we have invited a project from the infrastructure program. So this is also a tool that can really help the whole community. And Paolo will explain us a bit more what the project can offer to all of us. So thank you, Paolo.
Yes, this is a project on research infrastructure. And you see there the consortium. The consortium includes 12 among the most well-equipped and with the top level researchers in Europe, plus one gateway that is the University of Ljubljana to the east of Europe countries. What is the ambition? Essentially, we have been dreaming for this for years, also with Cécile, I must say. And the idea is to, one, try to find extra money, extra funds outside the mainstream of ICT. And the second dream is to try to help, to assist us, especially universities, but also industry, to educate and train the next generation of researchers, the ones that will go beyond the current robotics approach. And how this is done? By digging into the pillar of excellent science. Okay, so the Terinet project is in the excellent science pillar. There is a lot of money, there, that is mostly spent in ERC project or FET project. FET, we're also trying to propose a flagship on robotics. There is the Marie Curie program, but also research infrastructure. So the idea essentially is to fuel next steps in innovation and eventually in societal challenges by offering researchers the possibility to spend time into key labs in Europe. There are 2 in Italy, 2 in Spain, 2 in France, 2 in Germany, 1 in the Netherlands, 2 in the UK, 1 in Switzerland, 1, as I said, in Slovenia. So the approach will be this. So call opening will be in December, proposal will be collected, evaluated, and the preparatory phase, the access will be prepared, and then there will be transnational access in these 12 infrastructures. Who can apply? Researchers from academia and industry, students, even school students with brilliant ideas. We want really to encourage out-of-the-box thinking, the one that will lead to innovation later, but we want to really have brilliant new ideas tutored by brilliant students, because this is the idea, to have a critical mass of equipment, critical mass of researchers, critical mass of acting projects. And more than 2,700 days of access will be offered to 310 expected users and more. And what you see, while this will make a change, I already said, actually our ambition is, of course, to work in deep collaboration with the future digital innovation hubs, with the infrastructure we have seen, with industry, and also with the world. Essentially, the idea is to attract brilliant students from all over the world to contribute to make Europe a place to be, where new ideas, new and disruptive concept for the future robotics are encouraged. So here there are no limitations to the imagination of the students, in fact. This is the feature, if you will, of the excellent science pillar, and this is what we want to exploit.
Excellent, thanks. That's a new concept, very interesting. And I hope you will also spread the words to your students and then to also the industry, so they must be aware of this network, which we have high expectation about this project. So we are on time, incredible. So we made it, the 23 presentation are done. So you have now the whole knowledge, all the activities we are doing. And you know that every year I am also organizing a workshop about success stories. So I invite the 23 of you to come in 3 years or 3-4 years and come to present the success of your project. And in the meanwhile, I have 2 announcements. Number 1, we have prepared booklets with all the projects you've seen. They're there, so pick them up. Just a few information. Some of the names of the project have changed between the time they have provided the information and today. So there are 2-3 changes. So one for Microros, I think Robot Union is already the new one, I don't know. But anyway, these are the 2 discrepancies you might find. And second announcement, I invite you now to the poster session. We have a nice crew helping us to reach the place. They will indicate where the poster session is, so that you can also, some of the project were invited to bring posters, so it's an opportunity also because we've seen some similarity between projects. So I would like you guys to discuss among yourself to see how you can develop synergies. You have similar platform or similar sectors you want to work on, so please, it's the beginning of your project. Take this opportunity to discuss with the other project and start collaboration. And final word, I want to invite you tomorrow morning, first session. I think it's in this room. It's the first track, where number 1, we will present the success of previous projects. So it's very interesting for you starting a project to understand what works in projects. So it's a nice opportunity for you to discuss with them as well. And second half of the morning, we have a presentation for project offering services to the robotics community. You already had a gist of that with some of the project offering cascading, but we will have more tomorrow. So please join us tomorrow again for other interesting adventure. So now I invite you to follow the nice crew people in green, and they're our guest and host, and will show us the way to the poster session. And thank you again to all the presenters, to the people who helped me setting up organizing the session, and to have contributing to this nice brochure and to your good presentation there, and they are recorded. We will put them on our website, as I said. Thank you again, and I wish you great success in your project. Keep us informed. When there is news, a press release, and so on, please contact your project officer, and we need to show what our funding, it's 106 million euro. So we have to show to the policymakers, to our commissioner, when we have success project, or the vice president of the commission, ANSIP is extremely interesting in seeing concrete results. So when you have concrete results, tell us, and we will bring it to the highest level of decision maker. Thank you again, thank you for your work.